Alright, so it's time to tell you a little story about the ellipse. He's basically a circle that has been pulled, either vertically or horizontally. So it's stretched more in one direction. So the formula, as you see, is a little bit similar. The only difference is we can't set it equal to r squared anymore because an ellipse technically has two different radii. It's got one along the x direction and the y direction. So our center is still h comma k, but now we have two different radii because, again, it's being stretched further in one direction. Now your major axis is the long axis. It's kind of like the big diameter of the ellipse. And the minor axis is the short one, kind of like the short diameter of the ellipse. Now you're going to learn some new terminology for this section, and it's called foci. Now foci are little coordinates that's kind of like if you were to take a circle and you have the center and you stretch it, it's like the center splits. And you're going to have two coordinates and the major axis called foci. And to find the foci, we need to know c, the distance from the center, which we're going to use this equation right here. A squared is equal to c squared is equal to a squared minus b squared, where a is your major radius and b is your minor radius. So this is going to make a whole lot more sense once we start actually doing an example. So again, as you see, you're going to have to know how to complete the square with efficiency for this chapter to be able to graph these ellipses. Okay, so why don't you pause the video and try this first one on your own. So let's see if you were able to handle it. Again, first thing you want to do is you want to get your x's together. So we have 49 x squared minus 196x. And we're going to group our y's. We have 9y squared plus 72y. And we're going to move the 101 to the right. So this is equal to 101. And now what you're going to need to do is you're going to need to factor out the leading coefficients again. So this is the twist. And that's because there's two different radii for ellipses. So for your x, you need to factor out a 49. That's going to leave you with x squared minus 4x, and now half of 4 is 2, squared is 4, so we have our plus 4 for the x, but before you go to the right side, remember you have to multiply the 4 by 49, so you will be adding 196 to the right side. For our y's, we're going to factor out our 9. That's going to leave us with y squared plus 8y. Half of 8 is 4, squared is 16, so plus 16 on the inside. And we're going to add 144 after we multiply 16 by 9 to the right side. So now back to the left, we have 49 times x minus 2 squared plus 9 times y plus 4 squared, and that is equal to 441. And this is where we're not done. Now we have to do a little step where, if you look at the generic equation, the ellipse is always equal to 1. So we're going to need to divide everything by 441. Okay? Now, 49 over 41 is going to reduce to 1 over 9. So this is now going to look like this. It's going to be x minus 2 squared over 9 plus 9 divided by 441 is 49, 1 over 49. So this is y plus 4 squared over 49. And now we're equal to 1. But if you go back to the generic formula, we need the radii inside the parentheses. So there's one last step for this problem. So what we're going to do is this is our equation. We're going to make a big set of parentheses. Now the top is still our x minus 2, But the bottom is now going to be squared. So what number squared gives you 9? 3. So you take the square root of your denominator and you put it in the denominator inside the parentheses. Okay, now we do plus another big set of parentheses. Our y is still y plus 4, but our denominator of 49 is going to jump inside as a 7 because 7 squared is 49. And we are equal to 1. This right here is your final equation for the ellipse. Now, if you get that right, the rest is pretty simple. But if you get that equation wrong, unfortunately, you're going to get a lot of misleading information to finish this problem. So our center is at a positive 2, negative 4. So we're going to go to positive 2, negative 4, and we're going to place our center. Our Rx is the number in the denominator with our x's. So we have a radius of 3 in the x direction. So we go 3 to the right, and we go 3 to the left. But then our y radius is 7. So we're going to go 7 up, 7 up, and then 7 down, which puts us a little bit off the graph. And this is our ellipse. But we have 2 more pieces of information to find and graph, and those are foci. I don't know why I have 2 eyes there. So, the foci. How we find that is with the equation mentioned at the beginning. It's c squared is equal to your major radius, your big radius squared, minus your little radius squared. So c squared is equal to 49 minus 9. So c squared is equal to 40. And for this, we're allowed to just give us a decimal value. So the square root of 40 is approximately 6.3. So c is 6.3. Now c is the distance from the center that your foci are. Now here's my little tip. Foci are always on the major axis. So they are 6 above and 6 below in this case. So what I like to say, it's 6, so 1, 2, 3, 4, 5, 6, and a little bit above, and 1, 2, 3, 4, 5, 6, and a little bit below. Now the reason I say graph them first is so that way you can write your coordinates. Did your x value change at all for your foci in relationship to the center? No. So your x value is still 2. But your y value has. So your center is at 6, or 2, comma, negative 4, but we're going to go up 6 and down 6. So that's going to give you 2.3 for this top focus. And then we're going to go down 6.3, which is going to bring you to negative 10.3 for your lower focus. Okay, foci is the plural of focus. These things are called your foci, but an individual one is called your focus. So that is an ellipse for you. Again, it's a lot of work, but once you have the completing the square part done, it's a pretty simple thing to do. You just have to remember to put your 2 different radii, find your C, and add that to your center, either up or down or left or right. So this next example, you're going to get to see left or right. Go ahead and pause the video and complete the square to get the equation really quick, and then we will finish the job. So here we go. If you completed the square correctly, you would have grouped your x's and your y's. You'd need to factor out a 4 for your y, but x is already good to go. You'd get to this step right here when you would need to divide everything by 4. So 4 over 4 is 1. Remember, the denominator is 1. Square root of 1 is still 1. Over here, we had 1 over 4. So the square root of 4 is 2, which goes inside here. This is your graphing equation. Your center is at 1, comma 1. So we're going to start with our center. And then we have our Rx of 2. So we go 2 to the right and 2 to the left. Our Ry is 1, so we're only going to go up 1 and down 1. So we have a very small ellipse here. And here is our ellipse. Now to find the foci. Your foci are located at c squared is equal to 2 squared minus 1 squared. So c squared is equal to 3, which means c is approximately 1.7. But this time we are going to stretch along the x-axis, left and right, because that's our major radius. So we're going to be shifting 1.7 to the right and 1.7 to the left. We just have to state those coordinates. Now this time if you look, the x value has changed, so your y is the same as the center. So the y is going to be 1 for both of our foci. So now we just have to take 1, subtract 1.7, and we're going to get a negative 0.7. And we take our 1 and add 1.7, which is going to give us 2.7, and that is it. We are done. You have graphed another ellipse. So there is one more example in these notes, and I'm going to tell you that if you would like to do it, go right ahead, but I'm going to save that one for class time. So if you want to try it and see if you can do it on your own and check with us tomorrow in class, that's fine. If not, save it till class time so we can go over it step by step again to make sure you understand everything. All right, this is Longo, and I'm out. See you, bye.